In this video demo, I'm going to take you through the steps required to write a basic PLC program. So to begin with, we have to open up the software that allows us to write PLC programs, and it's called Studio 5000. So double click on that and then click yes to the launcher. And so it opens this pop-up menu, and we're going to create a new project so that we start from scratch. So you go to New Project, and we have to select the proper controller. First of all, you want to select on Logics, and then our family of controllers is the 5370, and this is the proper model number here, L24ER-QB-FC1B. That kind of defines the input and output modules that this unit has. So I'm going to type a name here. I'm just going to call it Lab 1 for now, and then click Next. And here all you're verifying is that it is the proper revision, and you can add a note or description here. So you can put the date and your name as an example. Maybe we'll call this Lab 1. And then once that's done, you just have to click Finish. Now you end up with this controller organizer on the left-hand side that we will make use of. But the very first thing we want to do is to create a path so that when we download our program to the PLC, it knows where to go. And that's going to be an IP address. So click on this icon. And this will come up with values here in just a second. And click on this arrow that points inwards. And you may have to scroll down until you see the PLC's IP address, which is 192.168.1.30. All of the PLCs have been programmed with that IP address. So expand that. You might want to move this to the left, and you eventually want to be able to see the controller. And the controller is module 0, which is right here. So I select that module, and then you say or select Set Project Path. Okay, and once you've done that, you can just say Close. And now up here in this space, you should see the project path, which is to 192.168.1.30 compact bus slot 0. So we've set up the basic project path. My next step is to create a simple program, and I'm going to select Main Program, Main Routine. And this should open up. I think you have to double click. It's going to open up a blank program. I call this a blank program, but it has a rung with no instructions on that rung. Another place that's going to be important to go to is parameters and local tags and controller tags. So let me show you the parameters and local tags. Right now, there are none. Okay. And down at the bottom of the screen is an important place to be able to access. One is called Edit Tags, and the other is called Monitor Tags. If you create a new tag, this is where you're going to go to create it and then monitor the value of that tag. Is it true or false, on or off? Another important place to go to is the controller tags. So I'm going to double click on the controller tags, and you'll see many controller tags here. And these refer to different modules on this embedded PLC. So the first module is Module 1, and it has many inputs. So you can expand on this to see the binary value, expand on this for the data. And to widen the window, just come up to the top here and widen that. So it shows you all of the bits that represent the inputs, which are discrete or logic digital inputs. I can minimize that and go to local 1 output. And this shows me all of my output data bits. Now you may notice that right now I'm offline, so I'm not actually seeing the real values. We will momentarily. So I'm going to close that off, close this off. And local 2 input are the analog inputs. We'll eventually get to that. And local 2 output are the analog outputs. So when we write a program, we're going to make use of those various inputs and outputs. Now we're going to modify the main routine, which if I double click here is the main routine. So up in the top here, all the different instructions that we have access to. The first one is the favorites. The next we'll use a bit is the bit. We'll be working with timer counters, compare instructions, math instructions, move instructions. So you just click on these lower tabs and you get all of the instructions that you may be able to use. So let me go to favorites, and I want to bring down an examine if closed instruction and an output energize instruction. So the outputs tend to be over on the right hand side, inputs on the left hand side. And I'm going to give each of these instructions an alias name. So I might call this switch 1. And once I've done that, I can right click on that name and it tells you that it's undefined. If I right click on it, click new switch 1, I want to make it actually an alias tag. So I'm going to select alias, and then a box opens up saying alias 4, and I'm going to select one of the controller tags and a certain bit of the controller tag. So I go to data, I select this bit, and I'm going to choose bit 0. So once you've done that, I have an address here, which is saying that this name that I've given that variable points to this address. So switch 1 is basically another name for this address. So it's called local, which means this machine, 1 meaning slot 1, I for input, and then it's bit 0 of the 16 bits. So once you've done that, select create. Okay, and it tells you that this is the alias, and below it is the actual address that it points to. Over on the right hand side, I'm going to say, I'll give it a name. I'm going to put light here, and just click anywheres, and then right click, say new light, and again it's going to be an alias, and it's an alias 4, and this time we want to go to an output bit, so local 1 output data. And we're also going to go to bit 0 and then do create. So now I have one rung in the program, and it tells me that this is my input, local 1 data in, and here's my output, local 1 output, data 0. Now we actually have to send this program to our PLC, because right now it's just in the PLC. And to do that, there's a menu over here that has a drop down, and we want to download the program. So download is the term for transferring the code we have on our computer to the PLC. So that just takes a second. You get this pop-up message just kind of warning you that you're about to run some code. For example, if this was connected to an elevator, an escalator, a motor, it may turn on or activate some hardware. So just be aware that that might happen. For us, it's just LEDs and switches, so not a big deal. Okay, it's finalizing the download. It's downloaded. Select OK. Now, one of the other things that you need to check here to know that the program is actually running is that it needs to be in the run mode. Controller should say OK, IO should say OK, and here it should indicate remote run. So check for all of those things. As well, make sure that you have green bars here, as well as over here. So now we're in a mode called monitor mode. We can actually watch what's happening here. Now I'm doing this remotely, so I don't have access to these physical switches, but if this switch was closed, then you would see this output come on. Okay, and we can actually now go to our controller tags. So here's our controller tags, and I can actually look at the inputs. So this is my input data. I can break it down into binary. And here it's showing me that I have a few inputs that are at a true state. The inputs are at 24 volts, not 0, but 1 is, 3 is, 4, and 5. So that means the hardware switches are actually closed on this PLC, or some of them are closed to give us 24 volts. So I'm going to make a change to the program and actually use data 1 to see that our output will go true. So what I'm going to do next is go offline. Okay, select offline, and now that you can see that the run is not green anymore and it's not in the run mode. So now I can edit my program. So back to main routine, and I'm going to change this. So edit these properties, and I'm going to make this a 1 because I know physically my switch is closed, so that when I run this program and I download it, it should turn on that light. So let's click download. And this just takes a few seconds. You'll get that same message again. And this is the point where we've basically written our first program. Okay, very simple program. And you want to save this program. So we'll do that right now. I'm actually going to save this program to the C drive on this computer. Then you could transfer it to your N drive or save it to the N drive directly. So I'm going to call it PLC Lab 1, and maybe I'm going to put Fall 2022 after it. Now the project files end in .acd. That's your program file. And make sure when you do create the file name, it shouldn't have any spaces or special characters. And then I click Save. Okay, and now if I want to reopen that program, I just go to File, Open, and I should be able to find that program. I'll do it as date modified, and you can see that I have it right here. But for now, I'm going to cancel that. So that's basically our first program. Our next step is to add the thermocouple module. So under IO configuration, or sorry, expansion IO, right click, new module. And we're going to search for the module that has IT6 in its name. And IT6 is short for input thermocouple 6 channels. So I'm going to select that. And then I'm going to give it a name. And I can just call it thermocouple module. Probably good enough. And I know that the thermocouple module happens to be on slot 5, physically on slot 5. And it's revision 2.001. I don't think you'll have to change that. And you could just add thermocouple module here if you want. This is optional. Okay, and now that I've done that, select OK. And then what it does here is adds to the expansion IO slot number 5, the thermocouple module. The second one we want to look for is IR6. And this is the RTD module. So 6-channel RTD. So select that and then do create. You can also just double click, and I'll call this the RTD module. Here we can just say 6-channel RTD. Okay, it's Series A, revision 1.001. Now that all that's done and it's on slot 4, that's something that's also very important. Select OK. And then once we're done that, we can click on Close. So what we've done here is added 2 expansion modules. So they're already physically attached, but now we have to specify that we do have these in software. So slot 4 is for the RTD and slot 5 is for the thermocouple. So we have those added now. My next step is to configure the IO modules. So in this panel, so you have to click on thermocouple module and then come over to configuration. And we want to select channel 1, 2, 3, and 4, because those are the only ones that actually have a physical connector to add a thermocouple. And here I want to change this to engineering units times 1. Same for all of these. And for the channel 4 as well. And these first 3 are going to be type K. That's the yellow thermocouple wire. So I have to select type K. Oh, I can't do it to the first one because it's disabled. So I'll select K and K, and then the next two are going to be T, and that's the blue wire. And I want it to be in degrees Celsius, and I want the open circuit response to be upscale for all of these. And what will happen is, if a thermocouple is disconnected, it will display the highest temperature for that particular thermocouple wire type. So it could be different for a type T and a type K, but it will go to its highest temperature value. It's a great way as a technician, technologist, to know that the input is disconnected. Once all that's been configured, click Apply and OK. And then we're going to do the same thing for the RTD module. Go to Properties, Configuration. We want to turn on, and actually we're only going to turn on 1 and 2 because physically that's all we have connected there. So times 1. And we are using a 100 ohm platinum RTD with a coefficient of change of 0.385 ohms per degree Celsius. We want the temperature in degrees Celsius and to go upscale when we have an error with no input attached. We don't want to disable the lead compensation. We want to set the current to 1 milliamp and the filter to 60 hertz. That's basically the default. Now click Apply and OK. Now, if I want to actually check the channels, I have to go online. So I have to go online, and the program is already downloaded in the machine. And actually, this program doesn't control or work with any of the RTDs and thermocouples. So now we select Download. We can go Download. You don't want to choose Upload because that's going to take a program that was on the PLC and bring it into the PC. So it's always Download. That's actually quite important. Okay, it's done downloading. So you can see that my program is running, but the purpose of downloading is that now we're kind of in a mode where we can actually go and look at variables that are stored in the PLC. So I'm going to go to Controller Tag and open that up. And I'm going to close this off, but I want to go to my thermocouples and RTDs. So slot 4 is the RTD. I'm going to open this up, and you can see here that I have two channels, channel 1 and channel 2, that seem to be producing a value. And actually the value for the temperature is 22.4 degrees and 23.3 degrees. It's being multiplied by 10. Okay, so I get actually 3 digits here and 1 digit of precision when it's converted. So that's the 6 channels, 0, 1, 2, 3, 4, 5. And now we're going to look at the thermocouple channels, and they're on 5 input. And you can actually see that we have channels 0 and 5 are turned off, but 3 of them are measuring temperatures, which are 22.7, 22.5. So they're all within about a degree of each other, which is typical. Okay, so it shows me that I've got the channels, they're working correctly. If I had one of them disconnected, it would go to a much higher value. But physically, all these channels have something connected to them right now. Okay. If I wanted to show you what would happen with a disconnected channel, we can do that. Okay, I'm going to go offline and just show you what happens with a disconnected. We'll do one channel for each of these. So I'll go back to the thermocouple module, go to configuration, and I'm going to turn this on, and I'm going to make it a type K. Okay, but it's disconnected. I'm going to make this a type T, but it's eventually going to be disconnected. So there's nothing connected to channel 0, nothing connected to channel 5. So I'm going to click Apply. And I'm going to do the same thing for the RTD channels. So up here, and we're going to, the only thing I should change is back to here. I want to make these times 1 as well. And and everything else is as I expected. And then click apply to save, OK to close that. Back to the RTD module, configuration. I'm going to actually turn all of these on. I want to set them all to ×1. This to ×1. Okay. And right now they're all PT385s. Okay, so let's click apply. Okay, let's download this. So downloading also places the controller in an online mode, which allows us to monitor the status or the values of the various tags. There we go. So now we can go to our controller tags. Okay, and we're going to go to local 5 input. Now notice this number on channel 0 and this number on channel 5. So this is actually 400 degrees, not 4,000. We have to add a 1 decimal position here. So this means that this channel doesn't have a thermocouple connected, and it goes to its maximum value of 400. And this thermocouple channel is a type K, but it's not connected, so it goes to its maximum of 13,700. So, be able to identify, especially the T and the K maximum values. So 400 for T and 1370 for K. Now, if we do the same thing for the RTD input on channel 4, oops, I went to the wrong place. We want to go to local 4 input, and here are our channels. And so channels 0, 3, 4, and 5 are not connected, and therefore they go to their maximum temperature of 850 degrees. Okay, so that shows you what happens to the upscale value. And notice that the variables in these channels are actually integer variables. They're integers. That's why we eventually have to divide it by 10 to get a real value. But I'll show you how to do that in just a while. All right, here we're going to create a couple of tags. So we have to go to parameters and local tags. And this is the symbol for a tag. And in this spot, and you have to make sure you're in edit tags, we're going to create a tag called thermocouple channel 1K. So I'm going to type it in, thermocouple underscore, don't leave any spaces, channel 1, and then K. Okay, so now that I've done that, so I've defined the label, but I want to say that it's going to be an alias for another tag. So that's the name I'm giving it, but I want to tie it to that variable, which is the thermocouple. So it's channel 5 input, and I've got to go to the data. And we want to connect it to channel 1 data. So it's local 5 input channel 1 data. That's the thermocouple channel 1, which I know is a type K. So I double click on that, and you can see that it says, here's the name, here's the alias for that name. I'm going to create a new one here. I'm going to call this pretty much the same, but I'm going to put real after it. So channel 1, type K, and then I'm just going to put real on the end of it. And I'm going to make this what's called a base tag. So I'm not going to put any alias there. Okay, so it's actually a base tag since it doesn't have an alias, but I do want to make a change here. I want it to be a real value. When I use that variable, I want it to be real. Okay, so now I have 2 variables. And one of the things you'll notice is that when the variable is an integer data type, it'll have this arrow pointing inwards because it can break it down into each individual bit, and it's a 16-bit number. So now that I do have that, I want to make use of some of these variables. So I'm going to go to my main routine, and I'm going to add an instruction, which is called a compute instruction, and I'm going to add a new rung. So I come down here, and this is the symbol for new rung. So I've added that new rung, and I'm going to, as I said, put a compute instruction on that rung. And my destination is going to go to that real value that I created. So I'm going to find that in the table of tags. And it should be right here, thermocouple channel 1K real. And notice that a real value will have a decimal place. Okay, 1 decimal place in this point. And then the expression, this is a compute instruction. So I'm going to take the variable that I had, and I can search for variables by clicking this. That's called Browse Tags. And I want to find the tag that is the integer value. Okay, and I'm going to divide that by 10 to give me a real value representing the temperature. Okay, so it's going to take the thermocouple data, and notice that it's coming from, it says alias for channel. If I hover over here, alias for channel 5, input channel 1. So now we're going to download this and see what happens. Just takes a second to do that. So I'm converting the integer value that is multiplied by 10, because it doesn't have any fractional parts to it. It's an integer, and then I'm converting it to real. And so now when I use that tag, it's going to be a real tag. Okay, so you can see if I hover over here, the actual value of that tag is 228, but when I divide it by 10, I get 22.8 and make it a real tag. So that's kind of the first part in what you want to do with some of the tags. My next step is to write a bit of code to do some comparisons. So the first thing I need to do is add another rung. And this time I'm going to do a compare instruction. And my favorite instruction here is not any of these, but this first one. Because basically with this first instruction, I can do anything that these do, like equate, not equal to, and so on. I'm going to do it with an expression. So I'm going to click on compare. I'm going to put it on this rung. And then I'm also going to add an output. So I'll go to my favorites, add an output. And I'm going to tie it to, I'll call it normal, because I want this light to come on when the temperature conditions are normal. So I've assigned the name, but I haven't defined it yet. So I have to right click, new normal, and it's going to be an alias. So I have to change it from base to an alias. And it's going to be an alias for one of my outputs. Here I'm going to use local 1 output data. In this case, let's go to 2 and then do create. Okay, so that tag, which is a Boolean, is going to go to local 1 output data 2. But now I have to have an expression here. And I'm actually going to add 2 of them. So go back to my compare. And when I have 2 expressions in a row, basically I'm ANDing them together. So if the first compare is true and the second compare is true, then it will cause the normal light to come on. Okay, and I can also do an OR if I put one above the other, and maybe we'll look at doing that as well. So in the expression box, I'm going to put the expression box here, get rid of that question mark, browse for tags, and I'm going to look for the tag thermocouple, the one we used before. And here's another thing that's very helpful. You can filter by typing in a couple of letters here, and it gets you to just the variables that begin with TC. So it makes it quicker to find. And then I'm going to say, is that variable greater than 20 degrees? Okay, so we're looking for the temperature equal to something greater than 20. And then I'm going to make this one. Again, browse for the tags and look for things that start with TC. Finds it, click on real, and we're going to say less than 30 degrees. Okay, and you can even put a .0 in there to kind of indicate that it's a real value, and I'll do the same thing here. Generally like to do that if I'm working with real values. So I'm saying if this real variable is greater than 20, the output of this will go true. If this temperature is less than 30, the output will go true. If this is true and this is true, then normal should illuminate or turn on. So I'm going to download this. And hovering over variables will be something very useful in troubleshooting because it allows you to quickly see what's happening with the variables. You can also go to the controller tags. You can also go to local tags, and we'll do a bit of each of those things now that our program is downloaded. Okay, you can see that this light is turned on because if I come over here and hover over that, the temperature is 22.8. So 22.8 is greater than 20 and 22.8 is less than 30. So this will go true, this will go true, and it turns on that light. So everything worked as I expected. In this part of the code, I'm going to create a temperature alarm variable to let us know when the temperature is below 20 or greater than 30, whereas the other one was checking for the temperature to be greater than 20 and less than 30. So we're going to add another rung. Come down to end, click on add rung. Oops. Be here and add rung. There's our new rung. And we're going to add another compare. But what we're going to do is add a branch instruction. And I'm going to put this compare into the branch. That's how I add a second instruction. Then another compare down here. And then we're going to add another output. So we want to go to favorites, output, and we're going to call this temperature alarm. And use underscore. And since this is a new variable, you can see it says undefined tag. So I'm going to right click on it, say new tag. And I'm going to give it an alias, another name for the actual hardware tag. And the hardware tag is going to be a light, and we're going to make it light 3. So it's local 1 output data, and then use this pull down window. You notice these are gray because they're used in the program. And then I do create. And now we're going to add an expression. So the first expression, and you could type it in, but I find it easier to browse the tags. Again, thermocouple. So we're looking for this real tag. And if it's greater than 30, this output is going to go true. Or we're going to say if it's less than 20, the output's going to go true. So we find thermocouple here. It's right here. And this one is going to be less than 20. So we'll just review this once we've added it. So this one is ORing. So this one is saying if this is greater than 30, the temperature is greater than 30 or less than 20, then we want this temperature alarm light to come on. Now notice when I hover over the variables, it's not showing me any value there. Now the reason for that is I'm offline. So let's download and go online and see what happens here. Now I'm doing this remotely, so I can't heat up the thermocouples to show you what will happen. But in this case, we shouldn't have an alarm because the temperature's not greater than 30 and it's not less than 20. So neither of these will go true, causing that temperature alarm to stay off. So these are both true, so it causes normal to come on. But neither of these are true. So this is false and this is false. So the temperature alarm is false. All right, what we're going to do next is to work with a trend chart. So here we're going to create a trend chart. And to do that, we have to go to Assets and Trends. You click on that and then you right click to add a new trend. And I'm going to give it a name. And we're going to say temperature thermocouples. Okay. And the sample period, that's typical to be 10 milliseconds. What that means is that we're going to capture a new piece of information every 10 milliseconds. Okay. So that's pretty quick. We could make it slower, but it's fine for now. You could add a description, but then we're going to go to next. Okay. And we're going to add some tags. So to do that, you'll notice that there's main program and lab 1. So we go to lab 1, you'll see that there's a whole bunch of tags, but these are all the controller tags. Okay, so we want to go to the program tags, and that's in main program. And here you'll see the tags that we created. Okay, you can actually use either one, but we're going to choose to use the thermocouple real value. And then you'd want to say add and then finish. Okay, and this is what a trend chart looks like, but we're going to make some changes. And we're reading the real thermocouple value. And I'm going to right click on this and go to chart properties. This is a place we're going to go often. So we've already have the name. That's already there. Then there's going to be display, pins, x-axis, y-axis. Those are the main ones we're going to work with. So the first thing I want to do is to change the display. And if you're going to print this, it makes much more sense to have a background that's white. So I choose that. And then every time you make a change, click apply. Okay, so you can see that now our background is white. Again, we go to chart properties. So you're going to be going there very often. We're going to go to pens. We have one pen. We can change the color here to maybe red. Click OK. And the width is the width of the line. So I'm going to make it just a little bit wider for now, but we can change it afterwards. It's going to be an analog type because it doesn't have just two states. It has many. And we're going to set the minimum and maximum. Here, my minimum is going to be 20. My maximum is going to be 30. Because we're just staying within room temperature, so that should be okay. And where the engineering units are, we want to put degrees Celsius. And our description is channel 1. I'll put K type. And then hit apply. Okay. And that's one of the steps. Again, we have to come up here, go to chart properties. And the x-axis is going to tell us how much time we have from the left-hand side to the right-hand side. Very much like an oscilloscope display. So we want to have 2 minutes going across. We're going to leave these grids as they are for now. Click apply. And that represents 2 minutes. So if you look over here, this says 11:01:13 over on the right, 11:03:13. So that represents 2 minutes from the left side to the right-hand side. The next change that we're going to make is to the Y scale. And we're going to use a preset based on the pens tab. So we're setting the vertical based on what we've put in the pens, and I put 20 to 30. The other thing that you want to change is the number of decimal places, and we want to have at least one decimal place. And once that's done, click apply. So now you can see that this is going from 20 to 30 degrees, and our room temperature is about 25. So when we run it, we'd expect to see that sitting in the middle. So I'm going to click on run. And over on the right-hand side, we see my pen, which is in red. And my range is 20 to 30. That's the variable that I'm reading. And it's 22.9 degrees. Okay, so my pen is at 22.9 degrees. And it'll just move along. I can get it to show less time on the screen. And basically what will happen is it will just scroll to the next position. I'm now going to create some extra tags that we're going to use in the program. So I want to go to Edit Tags, and I'm going to create a tag called Set Point. So that's going to be the desired temperature, and that's going to be a base tag. So Set Point's a base tag. I don't have to specify an alias. And I'm going to have another one called Deadband. Now, the only thing I want to change is that should be a real data type because it's going to have a fractional part, or could have a fractional part. So, oops, spelled that incorrectly. So we want it to be real. And there's actually a little pull down here that we can select real, I believe. If you put in RE, you'll get real. So double click on that. Same thing here. We want this to be real. I can just come over here, and if you type in a couple letters, you will get real. So set point, deadband, and here I want to have my upper threshold. I'm going to call this UT, and again, that's going to be real. And we're going to have the lower threshold, and that's also going to be real. Okay, now that we have these variables created, so this is how the user would create the variables, and maybe I want to set the variables to a certain value. So for example, I would come over here and click on monitor tags, and I'm going to make the set point 22 degrees, and I'm going to make the deadband 2 degrees, and then we're going to modify their values within the program. Okay, and so I'm going to modify the program, and I'm going to add some lines of code. Okay, and here I'm going to say that, and I'm going to use a compute statement. Sorry, bring this down here. And I'm going to say that the destination is going to be the upper threshold, and I've already created that variable. And the expression is going to be that the upper threshold is equal to the set point plus the deadband divided by 2. I'm going to put that in brackets, deadband divided by 2. Okay, and I've got that done. And then I'm going to add one more compute instruction and say that the lower threshold is equal to, just LT. Then I have to add the expression. It's basically saying that the lower threshold is going to be equal to the set point minus the deadband divided by 2. So for example, if the set point is 20 degrees and the deadband is 2, the lower threshold is going to be 19 and the upper threshold would be 21. So the set point is in the middle of that. Okay, so all of this looks okay. So what we can do is give this a try and put those variables in our chart. Okay, our trend chart. So I'm going to download this. So now I can go to my local tags and open this up, and this is showing me the current value because I'm online and these are my tag values. This is where I'd go if I wanted to edit the tags, but all of these tags that don't have an alias, they would be considered base tags. Okay, so thermocouple, channel 1, K-reel, that's a base tag. Set point, deadband, upper and lower threshold, those are all base tags. So if I go to my trend chart, which is right here, I'm not running right now, but what I'm going to do is add a couple of more tags. And I'm going to add the upper threshold, lower threshold, and set point. And we're going to make them different colors. So I go to chart properties, and we go to pins, and we're in pins, and we want to say add and configure. So that's the controller. We want to be in the main tag. And I think you can double click on some of these. So we want the lower threshold. We want the set point. No, I think we have to add them one at a time. So lower threshold. We want to add the lower threshold, and then we can do a search for upper threshold. That we want to search for them. It's UT. We want to add that and the set point. And add that. Okay, so we have the real temperature, the lower temperature, the lower threshold, upper threshold, and set point. There we go. We've added all those. So let me make the set point blue or dark color. And we'll make these purple. And it's okay that we have the upper and lower threshold at the same color. Okay. So maybe we'll actually make this a darker blue so we can easily tell the difference. So those are 4 values. And if we click apply and OK, you notice that they don't seem to appear on the chart. And that's because we didn't change the minimum and maximum. I believe we can do it right here. So we're going to make 20 for this, 20 the minimum, 20 the minimum, and then 30 the maximum for each of these. So that way they'll fit in the scale that we're working with. And apply and OK. And now we'll run this. Okay, now we see all our pens. So so you can see in this chart here that we have the pen that is the real temperature, which is going to change, the lower threshold, the upper threshold, and the set point. Okay, I maybe should have made it different colors, but I think 22 is the set point, and then 21 is the lower threshold, 22 is the upper threshold. And the darker line is my temperature, and it's at 22.9 degrees. So you see all those values. The 22 is the set point, 23 is the upper, 21 is the lower, and 22.9 is my current temperature. Here we're going to configure the input and output analog channels. So to begin with, you would come down here to where it says Embedded Analog I/O. The inputs and outputs are on slot number 2, as you can see here. So up in the top here, I have a few tabs, and we want to configure, first of all, the input configuration. So I'm only going to configure channel 0. So I have to enable it. I'm going to tell the system that I want to measure from 0 to 10 volts. And no units. The filter of 60 Hertz is fine. But here, I must change it to engineering units. And I'm going to go to upscale. So if a channel is not connected, and maybe we'll actually turn on the other one to show you what happens when there is no connection. And we'll make that engineering units as well, and upscale. So what should happen is it's going to go to 10,500 because that's the maximum analog input. So both of those are set to upscale. Click apply, yes, and then we go to output limits configuration. And that should be set to, we don't have the output turned on yet, so we'll turn it on. Okay, and we'll set this for 0 to 10 volts, and this to engineering units. When it's in engineering units, every millivolt will represent a value of 1. And so the range is from 0 to 10 volts normally, but it does have some overrange to 10.5, which is 10,500. So now that that's turned on, we should be able to go to output limits, and we'll make our output limit, we'll actually set it to 10,000. 1, 2, 3, and our low limit will be 0. And then click apply. And what that does is that even if you put a value of 10.2, it won't go any higher than 10 volts. It'll protect it from going higher than that value. Okay, so now if we go to the controller tags, and in this case, what I have is the output is connected to the input. So whatever value I send to local to output, and we'll do that right now. Okay, if I go to local to output, which is right here, and I'm going to send out 3.3 volts. So that's going to be 3,300. And then if I just click anywhere else, that should put it into the register. And then if I go up here, local to input, you'll see that it's at 3,308, which is 3.308 volts. Now you might wonder why that last digit is 8, but it's because you're not going to get an exact answer. This is an analog interface, not digital. And 0.008 volts out of the total range of 10.5 is a very, very small percentage. You can actually calculate it. The error works out to less than 0.1%. It would be 0.008 volts over 10.5 volts, a very, very small error. And you can see that the second channel, I don't have anything connected to it, so it went to the full scale voltage for that particular channel, which would be 10.5 volts. So whenever you see that value of 10.5 volts, it tells you that that channel is open circuit. And notice that all of these registers are integer values, all integer values. All right, for this part of the program, I'm going to create 3 variables. The first one is going to be called volts in integer. And it's going to be an integer value. The second one is going to be volts out. And then integer. It's going to be an integer value. And then the third one is going to be volts in real. And it's going to be a real value. As I said, you can just type in real. There we go. So now that everything is set up, we're able to write a program. Let me go back a step. I'm going to go back to parameters and local tags. I actually wanted to make these two an alias tag. So to do that, I'm going to go to edit tags. And I'm going to make volts in an alias to, let's find it here. So volts in is going to be an alias to local 2 input channel 0 data. And I'm going to make volts out integer an alias to local 2 output channel 0. Scroll down until I get to local 2 output. There are only 2 channels, so we're going to select channel 0. And then volts in is actually going to be created in the program. So I have these 2 set up correctly now. So let me go back to this main program. Okay, in this main program, I'm going to move the value 1000 into that variable I created. So I think it's volts in integer. And as I said, you can just type in VO and you'll get volts in integer. So actually I'm sending it to volts out integer. And the same thing here. I want to find that variable. And it's going to go 2000 or 2 volts into that output. Volts out into this value. And then go to volts out integer. And there we have that set up. The only other thing I need to add is I've created V1 and V2. So I have to define those tags. So it's just going to be right click, and go to V1. It's going to be a base tag. It's not going to any other hardware. And then I just have to do create. Same thing here. New V2. I just had to check that it's a Boolean data type, base, and then create. So what's going to happen now is when I manually turn this one on, I'm going to be sending out 1 volt. And when I turn this one on, I'm going to be sending out 2 volts. Now I'm going to add 1 more rung. So go up to here and add a rung. And I'm just going to do a compute instruction. So I have to do compute CPT. And I'm just going to say that the value that I'm reading in, okay, I have to find the tag here. So it's going to be the volts in. Search volts in real is going to be equal to, and that's my variable that I'm going to go to. Sorry, that's a mistake. We want to have the destination to be volts in real. I'm going to change the bottom one. Volts in real, and our expression is volts in integer. Okay, the integer value, I'm going to divide it by 1000 so that I get it as a voltage. And I'm going to put 0 on the end so I know I'm converting to real. So it's going to be whatever my volts is divided by 1000, ending up in that register. Okay, it doesn't like something there, not sure why yet. That's okay. We can, if you don't know what the error is, we can go up here and take a verify routine. Reference tag is undefined. So volts in integer, let's just double check that that's one of the tags. Volts in integer seems to be. The error that I had here was because my variable was volts with an S, and I was writing down volts without the S. So I have these three variables. So when I close V1, I'm going to send out 1 volt. When I close V2, I'm going to send out 2 volts. So let's download that and try it. So go to download.